Hey guys, welcome back to your AP Chemistry videos. This will be the second naming video in a series of 3. I think we'll have one more after this to cover how to name acids, but let's start with binary ionic type 2 naming. With a type 2 binary ionic compound, the cation can form more than one type of compound with the anion. And what that means is that cation is going to have two different possible charges. You could have FeCl2 and you could have FeCl3. The iron in each case has a different charge. In the FeCl2 it has a 2 plus charge, and with the FeCl3, the iron chloride 3, it has a 3 plus charge. Because of this, we have to make sure that when we name it, we specify that charge with the Roman numeral. And that Roman numeral comes after you name the iron. So this one would be something like FeCl2 would be iron 2 chloride, and if we wanted to name FeCl3, it would be the exact same thing, but it would be iron 3 chloride. So that Roman numeral always comes after your cation and it comes before your anion. You never need an anion, or you never need a Roman numeral for the anion because those charges are set. They never change. So you'll only need it for this first cation here if it has more than two or more than one possible charge, and that's the case with most transition metals. Sometimes, instead of using Roman numerals, we will change the ending of that cation. So instead of saying iron, we'd use a different form of it. We'd use ferric, or we would use ferrous. So we would change the name depending on which one we were using. If it was the higher charged ion, we would be using IC. So the higher charge is IC, the lower charge is OUS. Right? There we go. So for example, if we had CuCl, so that is copper chloride, if we just named it without using any of our Roman numerals or with our changing our endings, this would be copper chloride. But copper can change and have different charges. It can have multiple charges. You could also end up with CuCl2. Now because of this, we have to make sure we specify in our name that we would have the Roman numeral 1, so we know when we're talking about this that copper has a +1 charge in this compound and not a +2 charge. So this would be copper 1 chloride. All right, so if we wanted to name this using the different endings, we would have to change first the form of copper. So instead of it being copper, it would become Cup, and then we have to decide if we want to use IC or OUS. Now this particular copper is the +1 form, which is the lower charge, and since it's the lower charge, we want to use the OUS. So this would be cuprous chloride. And when you change these endings, you no longer need the Roman numeral. But either one of these names are technically going to be correct. Just make sure you read any questions and see if they specifically want one version or the other. If we were going to name this bottom one down here, it would be the higher charged form of copper, so it would be copper 2 chloride, or we would have to use the other one of cupric chloride, and that would let us know that we are dealing with the 2 plus version of copper and not the 1 plus version of copper. Like I said, if the cation is a transition metal, then it's going to need a Roman numeral to indicate the charge. There are two major exceptions to this. Silver is always going to be +1, and zinc is always going to be +2, so you do not need to use Roman numerals for these two elements, despite them still being in the transition metals. So you can ignore those Roman numerals for these two elements. Let's go through a couple more examples here. Fe2O3. So you need to know, if iron is in the transition metals, what are the two possible charges that iron can take? Well, I know from experience that iron can have a 2 plus and iron can have a 3 plus version of itself. So we need to figure out which one of these is it. If we're taking a look here, we know oxygen has a 2 minus charge, but there's 3 of them. So that means that this one, this iron, must be 3 plus, because if we go 2 3 plus charges, that'll give us a total of 6 plus. And if we have 3 2 negative charges, that'll give us a total of 6 minus, and they'll cancel out. So that means we know that this iron has to be 3 plus in order to cancel out the charges of the oxygen over here. So then when we name this, it's going to be iron 3 with the Roman numeral in parentheses, and oxide. And if we wanted to use the different endings instead of a Roman numeral, we could change this to be ferric oxide. And we use the IC ending because it's the higher charge version of that particular element. 3 plus is the higher charge, 2 plus is the lower charge. All right, let's do another example here. Let's go with MnO2. I know Mn is manganese, and I know that it's a Roman numeral, so I'm going to need something there. And I know oxygen we changed to oxide. So now I just need to figure out what is the charge of my manganese. And if we remember again, just like in the last example, oxygen always has a 2 minus charge. There's 2 2 minuses, so that's a 4 minus charge for our oxygen. And then manganese has to cancel that out, and to cancel it out, if there's only one manganese, it needs to have a charge of 4 plus. So we'll fill in our Roman numeral here of 4, and it becomes manganese 4 oxide. Another example, last one that we're going to do, cobalt bromide. So we have cobalt, and we have bromine. We'll change our ending to bromide. And now again, cobalt's another transition metal, so we need to figure out what goes in Roman numerals here. Bromine has a charge of 1 minus, but we have 2 of them, so that becomes a 2 minus charge total. Cobalt must cancel that out, and there's only one cobalt atom, so it has to have a charge of 2 plus to cancel out 2 minus, and it becomes cobalt 2 bromide. Okay, now let's move on to ionic compounds with polyatomics. These are generally the toughest to name because you're going to have to memorize a bunch of different polyatomic ions. These are now going to have 3 elements or more. They're no longer binary. Remember, binary means 2. And now if we have a polyatomic, that means we have multiple elements, more than 2 of them. And this usually occurs when we have oxyanions. And oxyanions are a series of anions that contain different amounts of oxygen atoms. The anion that has more oxygen atoms, we are going to change that ending to 8. And the anion with less oxygen atoms, we are going to change that ending to ite. So you're going to need to know the different possible oxyanions for each series to know when to use 8 and when to use ite. If we take a look at these two guys here, SO4 3 minus and SO3 3 minus, the one with more oxygen, so the SO4 is going to end in 8, so we know it's sulfur. But we change, whoops, forgot my L, sulfate, so we change our ending to ATE from sulfur to sulfate, and this one has less oxygens, so it becomes sulfite. There are instances where your series is going to have more than just 2, like we saw SO4 and we saw SO3. Sometimes they have a range of 4 different oxygen possibilities. And in that case, we need to denote the very highest possible oxygen count with the prefix per, and the very lowest possible oxygen count with the prefix hypo. And so if we take a look at this series here with chlorine, there's 4 different possibilities. We've got 1 oxygen, 2 oxygens, 3 oxygens, and 4 oxygens. The lowest one, we are going to use the prefix hypo, so we're going to name it hypo, and then it's chlorine, but it's a less amount of oxygen, so we need to change it to chlorite. So our ending here is still significant. You can't use chloride, you can't use chlorate, because chlorate refers to the higher possible oxygen counts down here. Then, if we go to ClO2, we're going to drop this hypo because it's not the lowest possible oxygen count. So that's going to become just our chlorite ion. And then we're going to move on to ClO3. This is our higher possible oxygen count now. So we have chlorate. We change our ending from ite to 8. And then the very highest possible amount of oxygens is 4 oxygens. So that's going to become perchlorate. And notice how the 2 highest end in 8 still, and the 2 lowest will still end in ite. Whoops, I forgot to change these here to subscripts, so I apologize for that, but let's just go through a few more examples and then we'll be done with this video. So this should really read Na2SO4. And if we want to name that, well, we know it's sodium. We want to check, is sodium a transition metal? Will I need Roman numerals, or will I need to change the ending of that name? And in fact, no, sodium is not a transition metal, so we don't have to worry about it at all. But now we need to know SO4. What is that polyatomic ion? And we just looked at that one on the first polyatomic slide. That's going to be sodium sulfate. SO4 is the higher possibility, so we have the ATE ending to refer to 4 oxygens rather than 3 oxygens. Now let's go down to the next one. We have Mn, that's going to be manganese. And manganese is, in fact, a transition metal, so we're going to need to use Roman numerals here. And then we need to know, what is this OH? And this should again be written as OH2. I apologize for that. What is this polyatomic ion? If you don't have these memorized yet, you need to get them memorized as soon as possible. This is our hydroxide ion. So we can name it magnesium hydroxide. Not magnesium. No, manganese. Sorry about that, manganese hydroxide. And then we need to use our Roman numeral to indicate the charge of that manganese. And it's going to be a 2 charge. Hydroxide is OH minus, and you've got 2 of them, right? So we have a 2 negative charge, and manganese would have to be a 2 positive charge to cancel that out. Now let's rewrite this guy again. FeNO3. 3 is what it should look like. This is going to be iron. And we know iron is a transition metal, so I'm going to need Roman numerals. And then I need to know, is NO3 my higher of the oxygen possibilities for that series, or is it the lower possibility? And with NO3, that's actually our higher possibility. There is no NO4. NO3 is the highest possible nitrogen-oxygen combination, so that still is going to have our ATE ending here. If it was NO2, then it would be nitrite, but it's NO3. And NO3 by itself carries a negative charge, the NO3 ion, which means if we have 3 of them, this has to be iron 3 positive to cancel out our 3 negatives for each nitrate. All right, now let's go the other way with our words, with our names to our formulas. Cesium perchlorate. So the first thing we need to check is going to be the charge of each one of these. And cesium is going to have a charge of, let me get my periodic table here because this one I don't have memorized. Cesium is in the first column of the periodic table, so it's going to be a 1 plus charge. And perchlorate, if you remember, is going to be a 1 minus charge. All right, so cesium is Cs, and now we need to remember, what is this polyatomic? What is perchlorate? Well, this prefix per tells us it's the highest possible oxygen count. So we know it has to be ClO, and the highest possible oxygen number is 4. So CsClO4, this would be cesium perchlorate, and we are done. 1 plus and 1 minus, they each cancel each other out, so we don't need to add any other subscripts here. All right, on to sodium hydrogen carbonate. Sodium, Na, and sodium is also in the first column of the periodic table, so it has a 1 plus charge. Hydrogen carbonate is going to be HCO3. An easy way to remember this one, CO3 is your carbonate ion, CO3 with a 2 negative charge. Anytime you add a hydrogen to one of your negative anions, that hydrogen is going to be like adding a positive charge. So it goes from a 2 minus to a 1 minus when you add that hydrogen in front of your CO3, 2 negative. So to make it sodium hydrogen carbonate, it actually makes its charge 1 minus instead of 2 minus. And look at that. The 1 plus and the 1 minus are nice. They cancel each other out. So our formula is NaHCO3, and we don't have to add any other subscripts here either. Our last one, sodium nitrite. Sodium again, Na, and we just used this one, it's 1 plus. Now nitrite. Over here we used nitrate, and nitrate was NO3. Well, nitrite has to be one less oxygen than that. So that's going to be an NO2 because that refers to the less amount of oxygens in the series. Now, what's our charge of nitrite? Again, that's 1 minus. So they both cancel out, and our formula is NaNO2 sodium nitrate. That's all I've got for you guys in this video. We'll have one more naming video to cover acids, and then we will be done. If you have any questions, let me know in class or some other time. Message me, email me, and I'll get back to you as soon as possible. Thanks, guys.